Hi guys, good day and welcome back to my channel. How was the last project? I believe you did well. All right, today's video we're going to talk about functions, nested loops, that 0x02 project. Okay, as usual, before we go into the task, we're going to look into the resources, what we're expected to know, nested while loops, C functions, what are prototypes, and C header files. All right, so let's get started. Nested while loop. Let's start with the nested loops. Okay, so I'm gonna use I'm gonna create a directory and I'm gonna call it functions. Okay, so let us cd into our functions that we've created. Okay, this is I'm gonna write my code for this very session. Let me clear the screen. Okay, the first thing you want to look at is nested while loops. So what is nested loops? All right, now let's take for instance we have seconds, we have minutes, we have hour in our time in our time. Okay, now you realize that each time there is 1 minute increment in the minutes, there is 60 seconds or 60 times increment in the seconds. That's to say you have to count 60 times before you count 1 minute. So the 1 minute is placed on hold. Let's say we have 1 minute 01, it's placed on hold waiting for the seconds to count 60 times, and at the expiration of 60 times the minute will increase by 1. Okay, the same thing is applicable to hour. The minutes have to count 60 times before it is applied plus 1 to the hour. All right, now that is a typical example of what nested loops is all about. A value must be held. Let's say the value must be held on ransom while the other values is counting. Let's say we have 2 for loops or 2 while loops. Okay, the first while loop will be hold on a place value. Let's say 1 is hold. Then whatever the second while loop is instructed to do must finish its task. Let's say the second while loop is going to count from 1 to 5. It's going to count 1, 2, 3, 4, 5. At the expiration of 5, the first while loop will increase by 1. Okay, depending on the conditions you set. That is a typical example of what nested loops is all about. Hold something at ransom, increase this other one. When you get to the expiration of that one, go back and increase the first loop by 1 or 2 or 3 depending on how you set your task. Let's try to see that in reality. Okay, I'm gonna first start with for loop because that one looks very easy to accomplish. So I'm gonna say let me create vi for loop.c. Okay, nested for loop.c. Let's do it that way. Nested for loop.c. Okay, because we need to start with our hash. Include iostream stdio h. For now, I'm not going to do the documentation of Betty, so let's go straight to the point. This is just for tutorial purpose. Then, and then, okay, open this. So I'm going to have 2 variables now. Let's say integer I, okay, and then integer j. All right, I'm going to start with for loop. So what I'm going to do now is the first one you'll count from 1 to 10, okay? But while counting 1 to 10, there will be 1 to 5 per session. So what I'm saying there is for I is equal to 0, okay? It's going to start from 0, or let's start from 1, actually. Okay, I is less than or equal to 10, and then I will increment I plus plus. Okay. Now, while you are doing that, don't print it out, but instead take another for loop. Now, this is what they call nested. The first one is here, and the second one is here. You can have 3, 4, 5 nested loops, depending on what you want. Example, you want to write time. I'm going to have second, minute, and hour. So for that, I'm going to need 3 nested loops, all right? So for this time around, j, it's equal to, I'm still going to start from 1, and then j is less than or equal to, let me use 5 for this time around, and then j plus plus. Okay, all right. Now everything should be in block. So I'm going to open a block for this very one. Okay. All right. And here, what I'm going to do is to print this value. But before then, the first value, the first for loop, will have to print a value for me. Let's say print f percentage d space, and no, let me say new line. Okay. And then the value of I. Okay. Now, what this means is that it's going to print 0 first. Oh, sorry, 1 first. It's going to print 1. While it prints 1, it will hold on to that 1. And then allow this second for loop to count 1 to 5 before it prints the second one 2. Allow this one to print 1 to 5 before it picks the next one 3. So take your mind to time. Assuming this was counted 1 to 60. So it's going to count 60 times before the minute increments. 60 times before the minute increment. All right. So with this, we have printed that. So when you print 1, okay, at this time around, you're going to print this second loop. So print for me, print f let's say percentage d space, okay, and then print j. All right, that's the end of that loop. Then when you're done with that, at every iteration, let there be a break of line. So I'm going to say butcher, and then I'm going to say /n. You can use printf, it does not matter. Okay, now this stage, I'm going to break the for loop. I'm going to return 0. Okay. Okay, so let's interpret this again. Look at this. For I, it's equal to 1, I less than 10, I plus plus. Okay, for the first time, I is going to be 1, so it's going to print 1 here. While it's printing 1, the second for loop will have to print from 1 to 5. So we're going to have something like 1. After 1, we're going to have something like this. I will delete it. So let me just put it in the comments. We're going to have something like this 1. Now, this one is printing 1 for the first time. Then, of course, while this is a new line, so it's going to come down. This one you have to print 1 to 5. Because there is a space here, it's going to print something like 1, 2, 3, 4, 5. Okay, that's how to dry run a program. So after you print from 1 to 5, it now moves to the next line of action. There is a break of line. So it will take you to the next line. It will go back again to a program. It has completed the first stage, but I is not less than 10. So it will go back again and take the next value 2. Okay. Then after taking the next value 2, it comes down to the next loop. So it will enter and then print 1, 2, 3, 4, 5. It will go back again, take 3, print 1 to 5. So take your mind back to time. This is what happens to your time. So at this first minute, this is 1 minute, it will print 1 to 60. After 60, it takes the next minute and then print 1 to 60 again, continuously till when the minute gets to 60, it will now switch back to hour. All right. So let's see how that works. Let me take this one off. Okay, so let's gcc end loop and then try to run the program. All right, so you can see this. We have 1 at the first minute, it prints 1 to 5. Second, it prints 1 to 5. Third, 1 to 5 until it gets to 10. That's nested loop. That's a typical example of how to use nested loop. Okay, so that's for loop. Let's try to implement this same thing using the while loop. Okay, so I'm gonna run, let's say vi nested while loop n while loop. Let me call it like that. .c. Sorry, I got network issue. Let me restart my network. Okay, so let's create the file again. Vi nested while loop .c. Okay, so hash include stdio.h and then integer main Okay. All right, I'm still gonna use the same integer I, and then integer j. Okay. Now remember that in while loop, you must initialize before you run the loop. So I'm gonna call my I equal to 1 because they're doing the same thing with the for loop. So I'm gonna call my j equal to 1 also. Okay. So for the first time, while okay, I is less than or equal to 10 in a block, I'm going to first print the value just like what we did in the nested while loop. So print f and then percentage d. So the first one was new line, okay, and then you print your I. Okay, now when you're done with that, your I will increment. You are done with that very while loop. You now pick the second while loop. So now while your j is now less than or equal to 5, all right, you're gonna print the same thing, print f, and then percentage d. There was a space here, and then we have to print I, sorry, j this time around. Okay, then you increment j, so j plus plus. All right, I'm gonna close that one. So at every point in time you cycle, there should be a new line. So I'm gonna use print f. Last time we used put char, so we can still use print f /n. Okay, and then you close the while loop, then return 0, then you close everything, the block. All right, so let's try to interpret this. At every time you print 1 to 10 or 1, print the second while loop. This is nested loop also. When you print the first value 1, ensure you take care of the inner loop first before you go back to print the second one. So you continue like that till when you reach 10, you stop the program. So let's run and see what happens. WQ GCC n while loop. Sorry about that. GCC n. Okay, so let's run. Oh, it's printing 1, 1, 2, 3, 4, 5, 2. What could be the issue? Okay, let's confirm. Let's check what could be the issue. So let me play this and VI into it again. Nested while loop. Okay, let's look closely to the program and see how it works. I this, j this, okay, fine. While I is less than or equal to 10, all right, prints this. Okay, I think I've seen the problem. All right, look at this. Remember that when you're using for loop, all right, you said I equals to 1, comma, or semicolon, I less than this. Okay, that means that at every stage you want to run the for loop, you must initialize I to become 0, all right? But if you look at this very one, your j is equal to 5, all right, or less than or equal to 5. Now, for the first time, it has actually counted your j to be less than or equal to 5, and this value here becomes 5, okay? So the j here becomes 5 because it has counted the value, all right? And then it's j, it's 1, 2, 3, 4, 5. So what is stored here, it's 5. So at each time the program wants to loop again, it realizes that j is already up to 5. So it will skip and move out of the loop, go back and pick the next value. All right. So what you should do is that at every time you want to use the inner loop, reinitialize your j to be equal to 1. Okay. I don't know if that's understood, but try to understand it. Now I'll repeat that again. Each time, the first time it counted, j was 1, 2, 3, 4, 5. And now what the j value hold here? What the j variable hold here is 5. So now, when it comes to the second one, to the second time, the I is initialized again. It counts 2. It picks 2 because it has not gotten to 10. All right. Now, when it comes into the second while loop, it realizes that the j is already 5 because it has counted 1 to 5 already. So it will skip this j, come out of the loop, and go back to pick I. All right. But now at every time you want to go into a second loop, ensure that your j is equal to 1. Reinitialize your j to be 1 so that it will not see j as 5, but rather it will change the value of j to 1 and then increment again. I hope that is clear. So let's see to that. WQ GCC n while loop. Okay, a dot out. Okay, so now you can see we have 1, it prints 5, 2, it prints 5 down to 10. So that's how to apply nested while loop and nested for loop. All right, so we move to the next thing on our list. The next thing is C functions. Okay, what's a function? All right, now let's see what that means. Let's just create a little program, a program that, let's say, add 1 plus 1 or 2 plus 2 or any number like that. Okay, so let's say pi add.c. Okay, hash. Okay, so let's have two values. Let's call it value integer num1, comma num2. Okay, all right. So if, let's say, I want to call for a user to put a value, so I'm gonna say printf enter num1. All right, slash, let's use slash t. We've discussed this before. Okay, and after that you're gonna scan f to get the user value, percentage d. Okay, the address of num1. Print f again. Now enter num2 slash t, scan f. So let's try to sum. Let's say that sum equal to num1 and then plus num2. All right, so let's declare the sum above here. We're gonna have something like this, sum. All right, now this time around we're gonna print the sum. So print f, let's say the sum of num1 percentage d and num2 is equal to the sum. Okay, so at this point in time, you're going to have the num1 first, the num2 second, and then the sum as the last value. It's going to print the sum of, it takes this value, num1, and num2 is the result. Okay, so after that, we will definitely return 0. Okay, and then we can close this. So now what you just successfully do is to write a program in the main function. All right, this is actually a function that's been created along in the C program, but we can choose to write our own function. The essence of function is this. Now, as you're growing in the program, you got to realize that you may need to write a code that may take up to 100 lines of code, up to 200 lines of code, but if you pack all those codes into the main function, it's not going to be user friendly. It's not going to be readable. All right, so it is best that you segment your code into functions and then be calling it, all right, for it to perform an action or whatever you want it to perform for you. So let's try to see how to write a function now. Okay, insert. So what I've simply done here is writing a program in the main function. So if I want to define my function, I can simply change it here, this name. There are several ways to do that, but let me start from the beginning stage. All right, let me delete this. Okay, so let me call this integer add. That's what my function name is gonna be. Integer. The first time is to declare the data type of your function, and then you write the function name. The add here is a function name, and then how many parameters how many arguments will my function take? It's going to take 2 arguments, which is the num1 and the num2. And then the 2 argument is going to take it's an integer argument. So I'm going to say integer, let's say integer val1. Okay, let me say num1. All right. And then the second one is also integer num2. Num2, okay? Those are the 2 parameters it will take. Now, when you're done with that, you don't need to declare this anymore here, right? If you do that, it will conflict your program. So this has to be removed. It will always see this when it's calling for the program. Okay. Now, at this point, I'm done with my my function. Then I'm gonna call the function somewhere. So what I'm gonna do is in here, I'm gonna start my integer main program. Note that my function is written above your main program. Sorry, your main function. Anytime you're writing a function, it should be written above your main function. If it's not written above your main function, that's when you need what you call a prototype, which I'm going to discuss in the next task. Okay, so I'm just trying to take it as a lower level. All right, so here I'm going to open this. Okay, so inside this main function, I will not need to write a code. What I'll simply do is to call my function above by calling the function name add in brackets. Let's say if I put something like 4, comma, and then 6. Okay. Let's terminate that and then close this. Of course, I need to return 0. Okay. Return 0. All right. So at this point, okay, when you say add 4 and 6, this 4 and 6 will go to your function you declared, and then your num1 will take the value of 4, and then num2 will take the value of 6. It will now look into your program and associate num1 and num2 respectively, and then sum up to give you the result. Then what you will see is just the result. So let's just run the program and see what happens before we go into something else. WQ, and then run the program. Num1, okay, sorry, 5, and then num2, 6. We have 11. But why is it not taking that A and 6? Let's see to that. Or the 4 and 6, rather, the one we actually imputed. Let's see to that. Add. Yeah, add.c. Okay. In here, we asked a user to put a value. Okay. So now for us to actually check if our 6 and 4 is working by calling the function. So what we'll simply do is to take this man off. Let's comment this line off and then close it here. You don't want it to take user input, just somewhat I gave it to do. So from here, it's just going to take this value 4 and 6 and then give us the sum to be 10. Let's see to that. Okay. WQ. Let's clear the screen and try to GCC add.c, then run the program. Now you can see we have the sum of 4 and 6 is 10. So that's how to write a function. Okay. Let's VI again into that. All right. So if I open this up, I don't need to declare here because it will always look for the content of my function and ask me to put a value, and then it will sum the value for me. So in here, we're supposed to have /n to take us to a new line after printing the result. Okay, let's have /n here. So now, if I want to maybe calculate again, I'll just simply need to change this value. Let's say 11. I don't need to write another program because it will always look into this and give me the result. So this is going to give us 17 as an answer. So let's see to that. I would say GCC add.c, clear this, and then a.out. Okay, so that gives me what? 17. That's the basic way to write a function. Okay. But having said that, there are four ways, or there are four types of function declaration. Okay. But due to the video length, I will not want to take it up to an hour. So let's leave it at this level. And when I come on live to talk to my subscribers, I'm definitely gonna explain in details those four functions. All right. And the link and the class is gonna be shared to you before the end of tomorrow Monday. So do well to join the session. All right. Okay. So let's go ahead. All right. So let's look into the next thing on our lists. The next thing here is what is the purpose of function prototype? We're going to talk about prototype right now. Okay, so what are prototypes? Now, like I said earlier, if you define a function and is not above, let's look into that. Add.c. Now, you can see that my function is declared above the main function. But what if this function was declared beneath, or like below the main function? What do you think will happen? This from here, right, let's see the main function from here, and then take it above. Okay, and then let's try to call that value at 5, 7. All right. Let's return 0. Okay, and then let's terminate this. All right. So now looking at this, it's supposed to call this function and print 7 plus 5 for us. Okay. But if you run this program, you're going to run into an error. Let's terminate this first because the function is declared below our main function. Let's understand that first. WQ and then GCC add.c. Okay. Now you can see here, warning. Implicit declaration of function add. Now, this add is not found, it's not seen by your main program. There is a warning, it's not going to have any effect. I think the program will still run if you try to run it. Yeah, it's still running, but it is just managing to get the value below. But if you try to run this in a normal program, or Betty or your checker is not going to check because there's an error. Warning is seen as an error. All right. If you use that minus wall and flags in GCC, it's not going to pass this these checks. Okay. So how do you go about this? That's when the function prototype comes to play. All right. So let's play this and see how to solve that problem. Okay. Add.c. Okay. So what you do here is to define the function prototype. And the function prototype is whatever you write on top of your function declaration. That is the integer add, integer number, and then integer n2. For you to do that, you simply add a prototype here. So int add int num1, comma, int num2, and then you have to terminate it. Okay. So each time you call this function, it will look into the prototype and then reference it to wherever you save the function. Okay. So let's try to run that again and see what happens. WQ gcc.c a.out. You can see that you have the result without the warning again. So that's what you call prototype. Okay. Another way you can implement this prototype is by writing it outside, by defining a header file. Now remember that we have written this program called add function with the standard input output header file. Now you can actually define your own header file. And the header file you want to define should contain the prototype of all your functions or whatever you want to write. Okay. You can also write all your header files in there and declare only one header file here. Let's see to that. Okay. Now I'm going to remove this prototype right here. All right. And I'm also going to delete this prototype from here. Okay, this is just a main function, and I'm trying to call a function because this add is a function. Just like when you say print if, all right, that's a function, and the function is written within this header file called standard input.h. So you want to define your own header file and save your own function that can be called, which is this add. Okay, so let me just save this one and leave it as a dot wq. If I try to run that program, gcc add.c, now it's giving me a warning that I've declared a function add that is not found. Okay, there's no reference to this add value. So you want to declare a function, you can, every function declaration or header file, every header file, it's gonna end by the .h extension. So let me clear this, and then I'm gonna call my header file the main.h. So I'm gonna say touch main.h. Okay, so if you list this, you can see this main.h. Okay, so anything I write in here as a function and then I call it in the C main file will be reflected. Now let's try to define what we mean by that. I'm gonna say let's open it, vi into main.h. All right, and here at a basic level, I'm just gonna declare that function. All right, the function was, the prototype was integer add, and then I had something like int let me just call a and then int b. Okay, as a prototype, and then let me write the function for the prototype, or the the function for the prototype. Int add a int b. Okay, and then I'm gonna say return at the basic level a plus b. Okay, return a plus b. All right, so right, then in your main function, which is the add.c, you must include that main.h. So have hash include main.h. Now, every user-defined header file uses a quotation mark, but the inbuilt header file uses this angle bracket, right? So let's run this program again and see what happens. gcc add.c. So now you can see that we have no complaint here because we've actually linked our main function to our header file, which is the main.h. So let's try to run the program, a.out. Okay, it's not actually returning anything. Let's vi into, now the problem here comes from the main because we did not print anything. All right, so let's go into the main.h and then try to print the value of a plus b. So I'm gonna say print f sum equal to percentage d, which is gonna take the value of a plus b. Okay, so I think we're done with that. So let's see what happens now, and escape. Right, so let's clear this, gcc.c, run that. So we can have here the value is 12. All right, so that's how to work with prototype. So that's the basic way to actually define that prototype of a thing. I know it's a bit technical. I will try to hold a live video where I'm gonna explain in details and we practice alongside. Okay, the link will be sent across to all my subscribers within the week. Okay, so let's clear this, then let's look into the next task here. C header files. I think I've explained what C header files is, even in my previous video. We talked about that. Okay. So I think that's is there anything you want to do here? No. In my next video, so it's not going to be too lengthy, we're going to now look into the task ahead of us, all right, to see how to understand the concept and what we are expected to do in each of the tasks. All right. So for now, bye bye.